I want to start by pointing out that the little creature in the cloud is my vision for what a cloud native is. It's sort of a bit like a Martian, but it lives in the cloud. And I think this is the best thing ever. And no one I have ever shown this to has been impressed at all. So hopefully this is the time when it changes and you all go, wow, a cloud native. That's the best illustration I've ever seen. But no, okay. So moving on. What I really want to talk about is you know, as we said, some of the ways that we can get cloud native wrong and some of the ways that we can focus on the wrong things and therefore not really achieve our goals and not really achieve what we were trying to do. But I think before we can figure out what cloud native isn't and is, I want to do a bit of a level set on, well, what even is cloud native at all? Because I think this is where I think it all starts to unravel and we start to see a lot of people with really different ideas about what cloud native is. So I started thinking about this when I saw an article on InfoQ, and it was Daniel Bryant sort of pointed to this article and he said, Bilgin Ibrahim, who works for Red Hat, so he's now a colleague, you know, hasn't he got a great way of framing it? And I looked at the picture and I thought, I just don't agree with that at all. And so this is the picture that I was worried about. So you can see it's really framing cloud native as an architectural pattern, and it's framing it as something that's a bit like SOA and a bit like microservices, but it's the successor to those. And I thought, no, I just don't agree. And I spoke to Daniel Bryant afterwards, and he said, yeah, a lot of people disagreed with this picture because they thought that the communication mechanism on the cloud native bit wasn't quite right and there should have been a bit more gRPC and, you know, a bit more of this. And I had to say to him, oh, no. I was way back in my disagreeing because I didn't think microservices should be there at all. And I didn't think it should be a conversation about architectural patterns. So this article that, you know, I so disagreed with, it's called Microservices in a Post-Kubernetes Era. And so of course, microservices is right in the title. So I can't really complain that it's talking about microservices. But it's not just this article that talks about microservices and cloud native as if they're really, really closely related. Even the Cloud Native Computing Foundation, if you go to their website and you look up what is cloud native, they say it's microservices and it's containers and it's dynamically orchestrated. So then that puts me in this kind of weird position because Bilgin knows a lot about cloud native and he knows a lot about Kubernetes. But, you know, so I sort of feel a little bit funny disagreeing with him because I know he knows more about the topic than I do. But I feel really funny disagreeing with the Cloud Native Computing Foundation because the clue's kind of in the name. They're the people who are supposed to know everything about cloud native, and yet they say cloud native is microservices. And at the time, I was a consultant in the IBM garage. And one of the things that we do is we help clients become cloud native. We help them adopt cloud native practices. And we also just, everything we write in a cloud native way. But most of the applications I was writing weren't microservices. And this goes back to what Dave was saying earlier as well, that, you know, we were in small teams. We didn't need the overhead of microservices. So did that mean we weren't cloud native, even though we wrote these things for the cloud? And I thought we were cloud native, but who am I to disagree with the Cloud Native Computing Foundation? And I sort of worry that, you know, every time I sort of stand up and I say the Cloud Native Computing Foundation is wrong, you know, then, you know, people are going to say, oh, maybe we won't invite you back. But actually, it's not just me who has a problem with this definition. So Sam Newman, a little while ago, he tweeted to say that an interesting side effect of the Cloud Native Computing Foundation being so closely associated with Kubernetes, you know, they sponsor it, is that he often ends up talking to people who think they have to use Kubernetes if they want to be cloud native, and you just don't. And the other way goes as well, that you can be using a lot of Kubernetes, and yet I think you can still be not cloud native. And I'm a little bit reassured that between when I first started talking about this and now, the CNCF have actually updated their website, and they've updated their definition of cloud native. So if you go to their definition, to their webpage now, and you try and look up what is cloud native, it's not actually on the webpage at all. It sends you to this cloud native definition, which is on GitHub. And so you sort of think, oh, okay, if this is on GitHub, I have a feeling that maybe actually this is changing a lot. This is something that people are spending a lot of time talking about. And sure enough, there's 18 people who've contributed to this definition. And if you look at the history, you can see there's a lot of commits. And then you can sort of scroll down and you can see there's a lot of commits. And then you keep scrolling and there's a lot of commits. And then you keep scrolling, and then eventually you get to the bottom. Some of those commits are things like translating it to different languages, but some of them are really changing the meaning of what cloud native is, or changing the words around to try and better explain what cloud native is. And as well, if you look at this history, the first commit is pulling it into GitHub from a Google document, which also had 11 drafts. So, you know, this has been through a lot of iterations to try and get it right. And what the definition, so, you know, I think the problem that they're trying to deal with is if you ask 18 people what their definition of cloud native is, you're going to get probably like 20, 30 answers. You're going to get a lot of answers. So, you know, some people will say it was cloud native means born on the cloud. This is arguably the sort of original definition of cloud native before microservices were even invented. Some people will say microservices, you know, including the CNCF 2 years ago. Some people will say Kubernetes, and those people are all talking to Sam Newman. Some people will say, actually, it's more to do with DevOps, and they might not use the word DevOps, but the ways of working that they'll describe, that optimizing for fast feedback and that kind of thing, and having small teams that are responsible for getting things out to production is very similar to DevOps. Some people, I think now, we almost use cloud native just as a definition, as a synonym for saying we built this in 2021. So if we say we're going to do cloud native development, because if you're not doing cloud native development in 2021, you must be doing something really old fashioned. I sometimes see as well, people forget that you are allowed to say just cloud, because we get so used to saying cloud native that sometimes we should be saying just cloud, and we end up saying it's cloud native, whether it is or not. And then sometimes people will say, oh, cloud native, it means it's idempotent. I don't see this used very often, because usually when you say idempotent, people go, item what? But what idempotent really means is rerunnable. So it means if you take your thing and you ask it the same question several times, you're going to get the same answer. That's really important in the cloud, where things may be spun up, spun down, you may horizontally scale. It certainly isn't how things were optimized to run before the cloud. So with all those definitions, what do we do? How do we even make sense of it? Well, I think we have to sort of step back to try and figure out, what problem are we trying to solve? Why are we even doing things on the cloud rather than in the data center? And the CNCF talk about this in their definition. So in their original definition, they say it's microservices dynamically orchestrated. And then they say, so you can build great products faster, which is, I think, really important. The reason to be cloud native is to give us that speed to market. It's to give us that ability to respond to customer needs. But let's step back and, think sort of like, what problem are we actually trying to solve? And sometimes I think when people adopt cloud native, the problem that they're trying to solve is that everyone else is doing it. And it's natural as people that if everyone else is doing something, we feel a bit left out if we're not doing it. And as well, that for really good reasons, we want to become better at our craft. And the way we become better at our craft is by looking around at best practices in the industry and adopting them. Cloud native seems to be a best practice. So we all think we should be more cloud native. But I think in order to that's not actually, that's a natural human tendency. It's not actually a good reason. So I think in order to figure out the reasons to be cloud native, we need to step back and figure out, why were we even going to the cloud at all? And the original reason for going to the cloud, way back in the mists of time, was cost. People could get really substantial cost savings by going to the cloud. That sometimes isn't necessarily the case anymore, depending how you're doing things. But the reason the cloud saved money is that instead of having to provision for maximum capacity and have enough servers so that your website could handle Black Friday or whatever your peak load was, you could scale up and you could scale down. So you're renting these servers. So on Black Friday, you have a lot. The rest of the year, you have very few. For Wimbledon have this even more, that for most of the year, their website gets hardly any traffic. And then for a few weeks in June, they have this ridiculous volume of traffic. So the cloud works really well for allowing them to cope with that. And so the reason the cloud saves you money is because of that elasticity of going up and down and up and down. But then we realized that there was actually a lot of other benefits to the cloud as well. It wasn't just about cost. It gave a lot of speed. And what I mean by speed isn't just exotic capabilities, although you definitely do get those on the cloud. So, for example, you can now program a quantum computer and run it on a real quantum computer on the cloud, which is amazing. If you're doing AI and you want access to a GPU or to one of the other chips that are specialized for AI, you don't necessarily want that in your data center. And you definitely don't want a quantum computer in your data center because it runs at a temperature which is colder than the space between the stars, and nobody wants that in their data center. So you can have these exotic capabilities. But when we talk about speed, what we really mean is that you can get to market faster. You can respond to customers faster. And this is because you can deploy faster. You can deploy more often. So that sounds perfect. Why wouldn't anybody want to be on the cloud? Because it's faster. You can have a quantum computer. You can have a GPU. And you're saving money and you're more elastic. Well, what happened when people started to try and move to the cloud is we had this idea that cloud computing was going to be like a utility. It was going to be like electricity. And a lot of people got electrocuted. it turns out that doing things the same way in the cloud that you did it on premises probably isn't going to work, and you're going to have all sorts of problems. So in order to try and figure out what was going wrong and what we should be doing instead on the cloud, we as an industry defined the 12 factors. And some of them I think have aged really well. Some of them maybe now seem more like how to write an application on Heroku rather than a general set of rules for cloud. But what the 12 factors we're trying to solve really is how to write a cloud application so you don't get electrocuted. And then we took those principles that were the 12 factors and we generalized it to talk about how to write an application to be cloud native. And so that really had nothing to do with microservices. It was actually before anybody was talking about microservices, we were already talking about how to write an application on the cloud so you don't get electrocuted. And I think in terms of those principles for what you should be doing, I think probably the most important one is this idea of idempotency. I can barely even say it. So, the idea that if your application's on the cloud, you have to be able to scale it up, you have to be able to scale it down. It has to be able to tolerate going away and coming back and being okay when it comes back. So all of that's really good. And you can kind of call that idempotent, but I wouldn't recommend it. So idempotent definitely needs a synonym, which is where we come to cloud native. But what we're seeing in 2021 is that just like cloud, it was really easy to get cloud wrong. I think it's pretty easy to get cloud native wrong as well. There's different pitfalls, but there's still things that just seem to keep going wrong. And because I'm a consultant and I go out and I help clients take advantage of the cloud, what I end up seeing is sometimes when they ask for help, they really need help. And so, these are some of the things that I've seen in the field that I would not recommend that you do. The first problem I talked about a little bit already, which is this magic morphing meaning, the fact that we don't really know what cloud native means, or rather, all of us know what cloud native means, but we all have different ideas, which means we don't really know what cloud native means, not in a way that allows us to communicate with each other. And communication is one of the most important parts of software development. And when we end up with this misunderstanding about what cloud native means, that can cause problems. So if we, if our stakeholders ask us to become cloud native, and what they really hoped for was that we were going to produce a whole bunch of microservices, and instead we just made an idempotent elastic application, that could be an awkward conversation. Neither person did anything wrong. They were just a bit unsure about what we were actually trying to achieve. And I think sometimes, we're often unsure about what we're trying to achieve. We're not doing enough asking why. And so then we can end up with, again, these sort of expectation mismanagements where our stakeholder really hoped that we were going to get that fast speed to market and beat the competitors by going to cloud. But we thought they wanted to be elastic and save money. So again, nobody did anything wrong. We just had a mismatch. And one of the things that we see a lot is that the goal now is microservices. Everybody wants to do microservices. We all see Netflix doing microservices and we say, oh, if only we could be as good as Netflix, if only we could do microservices too. But microservices, they're not a goal. They're an architectural style that allows you to meet a goal. But you need to figure out what that goal is. And you need to put everything in place to make it happen. So we spoke to a bank in Asia Pacific, and they were a legacy bank, and they had a big legacy estate, and they could see that their competitors were coming up and eating their lunch, and they couldn't move fast enough to respond to these competitors. So they sort of scratched their head and said, well, what's the problem? And they looked at all this COBOL and they said, that is the problem. We need to get rid of this COBOL. We need to get a modern architecture. We need to have microservices. And so we thought, great, yeah, we can help you with this. Yeah, we can really help you. And then they added, but our release board only meets twice a year. And so then at that point we thought, okay, you're going to need a different kind of help. We can maybe help there too, but we need to have a conversation about this release board, because it doesn't matter how many microservices you have. If your release board only meets twice a year, you're probably going to release all your microservices at once, which kind of misses the point, and you're not going to be fast. So why bother? You could stick with the COBOL. And again, I think, like what Dan and I were talking about at the beginning, I think containers are such a powerful technology and they enable so many things that I think we sometimes think, if I have more containers, I'm going to get more benefit. And if I have 500 microservices, that means I'm a really, really good software developer. If I have 1,000 microservices, I am an A-grade software developer. Well, not necessarily. And particularly if you have your application spread over 1,000 containers, but you didn't actually decouple it, then I'm not sure you have microservices. What you actually have is a distributed monolith. And a distributed monolith is kind of as terrifying and bad as a normal monolith can be fine. I think a distributed monolith is almost always not fine, because with a distributed monolith, you get those disadvantages of the normal monolith in terms of you can't move very fast, but you get these extra disadvantages as well, which is that in a normal monolith, you get compile time checking. So if you change a method signature over here and it breaks something over there, it's going to tell you. Your IDE is going to tell you, your build is going to tell you. With a distributed monolith, you don't find that out until integration test, and only if you do integration test. And there's other disadvantages as well, because the system is distributed. That means we need to think about the distributed computing fallacies. In a monolith, if I call another function, it's going to execute. I don't even need to worry about that. In a distributed system, I need to think about whether it's going to execute. Is it going to be there? What happens if it doesn't execute? How do I find a backup? So that's a lot of extra overhead. So there's some pretty good reasons not to do microservices. Dave mentioned one of them as well, which is, have you got a small team? If you've got a small team, you're not going to get those benefits, but you're going to carry the cost. If you're not planning to release these things independently, don't bother. If you don't, with a microservice, I mentioned the complexity in invoking a function. The best way to handle that, because you need to think about a whole bunch of things. You need to think about discovery. You need to think about failover. You need to think about security, because this thing can't be exposed to everybody. So how do I say I'm allowed to invoke it? And so once you end up with all of those requirements, usually you need something like a service mesh to make it work. I think sometimes service meshes have a bad reputation as being really complex. So we say, oh, no, I'm just a small team. I don't need a service mesh. Instead, I'm going to write something to handle the security. I'm going to write something to handle the failover, that kind of thing. And then actually you have a service mesh. It's just that it's a service mesh that you wrote, which may not actually be an improvement over a service mesh that someone else maintains. So something to think about. And another really good reason to not do microservices is that some domain models, they just split really nicely. You can say this has to do with this, this has to do with this. Here's these 1 or 2 touch points. Sometimes you don't get those neat lines. And when that happens, if you try and do microservices, what you end up with is cloud native spaghetti, which again, kind of like normal spaghetti code, but way worse. So I was called in to help a team, and they were having a real challenge. I should say as well, this was a small team that was maybe shouldn't have even been doing microservices, but they were doing microservices. And they said, every time we change one microservice, another breaks. Now, if you've been paying attention, the dream of microservices, the big selling line for microservices is that it's decoupled. You can make changes over here, and you don't need to talk to the people over there. But of course, you have to do work to make something decoupled, and the domain model has to support that. Just being distributed doesn't mean that you're decoupled. All it means is that the consequences of being coupled are way worse than they were before. And so just because you're in the cloud, just because it's sort of cloud native, doesn't mean it's not spaghetti. And I love this illustration. This is from Cloudy with a Chance of Meatballs. And you can see that spaghetti in the cloud, not an improvement over normal spaghetti on your plate, because it's big and it fires meatballs everywhere. So when I dug into why this system was so brittle and why every time they changed something, something else broke, I looked at the code and I thought, this is strange. I'm seeing a lot of repeated code in each of these microservices. And it was because the object model, the domain model, was fairly big. So there was about 20 classes in it. Some of the classes had 70 fields. And they didn't want to be coupled. So they didn't use a common shared library, because that's a bit of an anti-pattern in the microservices world, because then you have this point of coupling, and the whole point was to be decoupled. So they said, in order to not be coupled, we'll copy and paste this object model across each service. But of course, what happened is it was still coupled, because anytime anybody changed a typo in a field name, all of the others would have to be updated or they would break. And so this is where it got so fragile. And really, that object model was just too common. So how it's supposed to work with microservices is that you have your microservices, and each microservice has its own domain model, and there's no overlap between those domain models. What was happening in this case was there was a single domain model for all of the microservices. So even though the code was duplicated, it was still the same domain model. And again, I think as a sort of a way of thinking about being distributed and being coupled, this is a very sad story, but I love it. It may not be obvious from the illustration, but this is the Mars Climate Explorer. And it was a rather sad space exploration story. This is what it looks like when it's the actual photograph. And you can see it seems to be made out of like a bin liner. And I think there's a little bit of sellotape holding it together, but that actually wasn't why it had problems. And what happened to it is it was supposed to go to Mars and orbit around Mars. And instead it went to Mars and kept going, and that was the end of the Mars Climate Explorer. And when they looked into what had happened, they saw that it was supposed to be, there was sort of a ground unit and a unit in space. And they were developed by independent teams. So this is, they didn't call it that, but classic microservices, completely independent teams. They were so independent that the space unit used metric and the ground unit used imperial. And so in this case, distributed definitely did not help. It could not have been more distributed, but it had a horrible failure. So really, whether you're using microservices or not, you need these consumer-driven contract tests to try and flesh these problems out. Another problem I see a lot has to do with continuous integration. I'll visit a customer and they'll say, we have a CI/CD, but a bit like Agile, CI/CD, it's not something you buy, it's something you do. You have to be continuously integrating. You have to be continuously delivering or deploying. And so when I hear things like, I'll merge my branch into our CI next week, or, we're talking about our CI/CD, we're talking about our CI/CD, and we release every month in CI/CD, I think we sort of forget that the C in CI/CD is continuous. And so if you're not actually doing it with any kind of regularity, it's not continuous. And of course, there's different answers about how often you should do it. So when you're thinking about integration, which is pushing to trunk, you could do it every character. That would be genuinely continuous. It would also be ridiculous. You could do it every commit, hopefully several times an hour. You could do it every few commits, hopefully several times a day. You could do it once a day, once a week, once a month. You could do it once every 6 months. I would recommend that you try and do it at least once a day so that you're following trunk-based development. And anything else, not so good. I personally really like to do it somewhere between every commit and every few commits, and then that solves a whole bunch of integration problems. So how about releasing? Well, you could do it every push, every user story, every epic, once a sprint, once a quarter. We used to do it every 2 years. If you're going to do it every push, you need to have a really good handle on feature flags. It's a bit scary. I think doing it once a sprint, that's probably a reasonable thing to aim for. Every 2 years is a bit old school. So, and the others are pretty good too. So what about the CD, which is testing and staging? Really, that's, and in CD, that's continuous delivery. You've got to do that every push. But what often happens is we have these CI/CD systems, but the business is terrified of releasing. So then we want to step back and say, why? What's stopping more frequent deploys? Isn't that the point of being cloud native? And one thing that happens is that coupling between the microservices. We can't release a single microservice. We have to wait till they're all ready. Well, that wasn't how microservices were supposed to work. Sometimes we get a sort of a business thing as well, that we can't ship until every feature is complete, but you want to get that feedback early. So you should be trying to get things out at least to a subset of customers to get the feedback. Because the whole point of cloud is the speed. And so what's the point of having an architecture that can go faster if you don't go faster? And you would never drive a car like this without the feedback. But somehow when we're doing product development, we wait for ages to get feedback. But feedback, it's just good engineering. It's just good for business as well. And if actually exposing things to users is too scary, there are things we can do. We can release things, but not actually wire them in. We can use feature flags to control who sees them. We can do A/B testing, canary deploys. What a lot of those need is quite good automation and quite good testing. And again, this is something where I think teams sometimes fall down a bit. We always have really good intentions about automation, but we're going to do it someday. And so I always get really worried when a team say our tests aren't automated, because what that basically means is we have no idea at this particular moment if our code works until we do a manual set of tests. It could be broken and things will break. Systems will behave in unexpected ways, and even if we're perfect, things we depend on might change their behavior. Another reason teams are reluctant to release is basically we don't trust our code. we're not going to ship until we have confidence in the quality. Well, this comes back to, you need those automated tests, and you need integration tests and contract tests for your microservices. And you need to love your build and respect your build and pay attention to your build, and not wait until someone comes and tells you that the build is broken. So build status should be front and center for everybody to see. It should be part of the furniture. And when I join a team, usually the first thing I'll do is I'll look at the build. And if the build on one team, I said, oh, look, the build's broken. And they said, oh, yes, that build's been broken for a few weeks. Well, that's bad. We should prioritize getting the build green and keeping it green, because it's what allows us to release. Another problem we see with cloud is that we don't use cloud in a very cloudy way yet. So sometimes architecture boards and things like that, they haven't caught up with the world of cloud yet. So they go at a completely different pace and they stop making sense. There's a story that many years ago, IBM sold a little cloud solution to a client, and it would allow them to provision virtual machines, but they came back and they complained about it. And they said, this software doesn't work. And we looked into it, and it was supposed to provision a virtual machine in 10 minutes. This was a long time ago. But what the client was seeing was that it took 3 months to provision a machine. And it turns out the reason was that they had put this 84-step pre-approval process in front of the provisioning. So I'm amazed they managed to get it done in 3 months, really. And I see this all the time, that we have this wonderful cloud, and we put so much governance on it that it's this cage, and then we have this sort of all this paperwork. With the cloud, one of the reasons that governance comes in is to try and stop the cloud just becoming this money pit, because if we're not careful, that can happen. And the beauty of the cloud is that it makes it so easy to provision hardware. But of course, that hardware, it's still a physical machine somewhere. It still has a cost. And of course, just because it's on the cloud doesn't even mean it's useful. So what we see a lot on the cloud is people spinning things up and then forgetting them, and then they just keep staying there eating costs. And I did that when I was learning Kubernetes. I created a cluster, I went away, I went on holiday, and the whole time I was there, it was just burning money for no purpose. And I love this quote from Peter Drucker, and he says, there's surely nothing quite so useless as doing with great efficiency what should not be done at all. So just because the cloud means we can, doesn't mean we should. And there's environmental reasons for that as well, which is it causes climate change. So we need to try and figure out a better way to manage our cloud that's not heavy governance. So we're starting to see things now like cloud to manage your clouds and multi-cloud management software. But even with that, ops is still kind of hard in the cloud native world. We need to do things in a different way. So we're seeing new disciplines like SRE or site reliability engineering. And with all that, the goal really is that we make releases deeply boring. I'm going to tell one final space story. This is a Russian one. And back in the 80s, they managed to brick one of their space probes. And what had happened was that they had this was machine code that would get uploaded to the space probe. And it would basically run the equivalent of a linter, but it was broken. And an engineer really wanted to get their code onto that space probe. So they just bypassed the automated checks. Unfortunately, what happened was that they basically turned the power off on the space probe. Nothing could ever get that space probe back. So we had this completely unrecoverable system. So when we design our systems, wherever we can, we should be trying to design them so that they're recoverable. And the way to do that is to minimize these handoffs and have as much automation as possible, and to not bypass the automation. So I want to end, so I've told a whole bunch of sad stories and people doing things wrong. I want to end on a happy note, which is cloud native can be amazing, and it can, you can succeed at it as well. You just have to be clear on what you're trying to achieve, and then always, always, always optimize all of your systems so that you're getting that feedback. And with that, hopefully we've got a few minutes for discussion. Thank you.
Yes, we've got.
Yes, we do. Thank you, Holly, for the session. Really enjoyed it. And like Florian said, I like the part about microservices as well, because I think now it's
the envy in you, right?
I think now, I don't know, the world is pretty much in a good state. There was, I think, a couple of years ago, it was the whole microservices hype where everybody wanted to do microservices, and now people are weighing more the pros and cons and making better decisions, I think.
Yeah. One of our consultants, he has this rule that when he goes and talks to a client, if they say microservices, fine. And if they say microservices and then they say Netflix, he thinks, okay, maybe this isn't quite right. But if they say microservices and then they say coupling and then they say cohesion, he knows that they're thinking about the problem in the right way, and they have, sort of a handle on what they need to succeed with microservices.
I very much like the fact that you mentioned the green factor, right? So, burning consumption. I don't care about the cost in money, to be honest. I mean, who looks at the money? I mean, we all have them.
Someone else's
that's
problem.
because your customers pay for for hosting the services you build.
Exactly. Yeah. No. But yeah, I think it's an important thing to consider. And it's also a thing that we discussed with your colleague, Jamie Coleman, right? He was also very passionate about that, and I very much appreciate this.
Yeah, I think sustainability has become a quality of the architecture. And
yeah, absolutely. Yeah, we were we're seeing this more and more, which I think is so good, that when you look at your ILIDs, sustainability is one of your ILIDs that you need to be thinking about, as well as scalability and everything else.
I was wondering if you could share with us, our participant, what's the IBM Garage?
Yeah. So the IBM Garage, so we're a services organization, and really what we try and do is we try and do cloud native development, help clients become cloud native, and we do this. We've got this thing that we call the IBM Garage method, and we've pulled in a lot of what we think are the best practices. So extreme programming, so pair programming, test-driven development, some of those lean startup ideas that are really, again, optimized for feedback, and then design thinking as well. So this, the idea that you don't want to just do technology for technology's sake. You need to figure out whose problem you're solving, and then figure out how to solve it, and start with the problem and then work back to the solution. Whereas as techies, I think, we always want to start with a solution. We go, oh, look, there's a cloud for that.
Tools, we've got techniques, we've got
cloud. Yeah, I want to build it, so I don't care if it's useful. But we just step back and say, let's think about that first.
One of the things that we're doing at Codecamp, we're connecting the community, and I'm really happy that Rocky Lotta is already with us. Hi, Rocky, can you hear us?
Yes. Good morning, everyone, or good afternoon, good evening, I guess.
Hi, welcome to Codecamp. I think we're really lucky that we got you together here in the break, during the break. Because first, if you don't know each other, it's a good opportunity to get acquainted, and then maybe ensure a continuous flow of the conference. I mean, we need to do something to feel like we're not in person, but we need to try to connect a little bit more. So
exactly. So these are the kind of conversations that would have happened in the hallways, and
yep. This is welcome to the hallway.
Right. Well, it sounds, Holly, like you and I share a very similar view in a lot of ways. Although I only heard the very end of your talk, but I think
that was by design, So it's a very nice flow of the conference so far, right? So they started with the entire scaling and good software engineering. And now you guys got together and discuss microservices or not, or Empire, or what are the alternatives?
Yeah. So what are you going to be talking about, Rocky?
That is not unlike actually my talk, which is I'll talk about microservices, but in the context of other distributed architectures that we've tried over the last 25 years or so. And I think, we're starting to see a backlash against microservices, and which I think is fine, because we should have more balance.
Yeah.
But I hope we don't go all the way back to some of the bad architectures, right, that we tried in the 90s.
Yeah.
So,
these things always seem to go in that cycle, don't they? So, we see sort of distributed to centralized, and each time it seems to go too far in one direction, and we can't just come up with something that's in the middle, because then it means that it's complicated, and I think we all want easy answers, don't we? So we want to know what the answer is, and then I'll just go and do it. If it's microservices, I'll do microservices. If it's monolith, I'll go do monolith.
Right. Yep. Yeah, I agree with you, and I think the problem is, for most of us, if we're doing interesting work, it is complicated by its very nature. And I've worked on projects over the years that are not complicated, and sometimes we chose an architecture that was also not complicated. That was yay. But too often, and I think that's your point, Holly, is we had a not complicated problem space that we complicated ourselves by picking, we're going to try this new architecture or this new technology, and it was like, really, we didn't need to do that.
We do it because we can, I mean.
Yeah.
Excellent. So really glad that we had this tidy conversation, and that we got to introduce you. I don't know if you knew each other before, but hopefully that's going to be the beginning of a beautiful friendship, because this is what's happening at Codecamp. So Holly, thank you very much.
Thank you for inviting me.
We're looking forward to have you back
Next time.
in the region, in Romania, in Iași, in Cluj.
Next time. Yeah.
Exactly.
I'm very happy to come
Thank you so
back.
much.
Yep, thank you.